¿Cómo estás? ¿Cómo estás? How is everybody? Okay, so I started a bit late today. I completely got into something else and I lost track of time, right? But yeah, we are going to, understand this problem very well. Uh, Hold on, not this one, not that one. That's a different question I was trying to solve. You see, this is why I hate. Forgive my interruption. So I want to do this quickly. Let's clear something out of the way, and I will start really, really soon.
How far will not
Oh, sorry. Again, another interruption. Christ. Oh, this is so much distraction to handle today. Hey, for everyone who is watching right now, I am. Okay, let me quickly. Oh, you saw that. Jesus. I don't know why I kept that open. But let's close this. Okay, that's fine. So we can I can use this now and put this here. Great. So this is the question that has been stressing me out. I finally understood this question, but it took me some time, right, to solve this question. And you can see, my submissions so far. But there is something else you need to note. Read the in case you are trying out this question, I'll suggest you read this editorial. It's really it's really detailed and well explained. And the algorithm I went through it was sliding window. I mean, you can choose the second uh, the second approach, which is using binary search, but I didn't want to get too much into that, right? I mean, binary search already is good. I mean, you can read this as well, but I prefer the first solution because it is easier to understand for me, right? And yeah, so let's see. Um, let's explain this question a little bit, and I think that's all I will do for now. this session. I don't know how long I'm going to stream today, to be honest, but let's see how far uh, I go with this problem. Okay, so let me bring my stylus, and yeah, so we have. Okay, I can use this color now. There is this way of solving problems, Leetcode questions using sliding window, where you have 2 pointers, right? Now, a sliding window, after a while, right, you begin to realize a sliding window is simply 2 pointers, right? You have a left and right pointer. Now, the difference here with sliding window is that with the 2 pointers used in sliding window, the right window moves to expand. The right pointer moves to expand the window, and the left pointer moves towards the right to contract the window, right, to shrink the window. So when do we shrink the window and when do we expand the window? Now we continue expanding the window. Typically you always have to expand the window, right? But the shrinking is where things become interesting, because the reason why we need to shrink a window is when the condition that the items within the window. So what was I going to say? When the items within the window, right, within the left and right pointer, are violating a certain condition, right, then we shrink the window so that we can remove some items from the window in order for us to you know stay within a certain criteria, or follow a certain condition, or respect a certain condition. Now, a typical example, right, is this question. But before we get to this question, right, I want to use the maximum sub array sum problem. Right now, the maximum sub array sum problem is such that we want to find the maximum item, or the maximum sub array that is part of another array, right? Such that the sum is going to be larger than every subsequent item in the array, right? So for us to do that, right, we need to use 2 pointers, or the sliding window algorithm. Now, the sliding window algorithm consists of 2 pointers, right? In this case, we want to find. Let me remove this here. So let's say this array here. I'll write out an array. I'll call this 1, 3, 7, 7, 4, 6, and then 11 here, right? So we want to find the maximum sub array sum in this array. Now, the maximum sub array, right? The maximum item in a sub array such that the sum of those items add up to the maximum we can get in this array. Now, a typical way we can do this is to, first of all, add every item in the array subsequently, right? And when we get to a point where an item, the sum becomes less than the other items in the array, we shrink the window, right? So let me show you what I mean by that. When we say when we want the maximum sub array sum. Okay, so let's say the maximum sub array, right? Typically they will give us the length of the sub array. So we want to know, let's say, a sub array of 3 items, 2 items, or 4 items, for example. So if we know the length of the array, we will still use a sliding window, but the way we use the sliding window in this case is quite different, right? So we'll start. First of all, let's say the sub array has to have a length of 2, right? So we want 2 items such that the sum of those items, right, is the maximum we can get in this array X here. I'll call this X. Sorry, this is going to be X, right? This is our X array. Now, for us to find the maximum sub array sum, right? And the sub array has to have a length of 2. So I'll say K, right, is equal to 2. Now, K represents the size of our window. Now, when we know the size of our window, typically what we want to do is to set the left and right pointer to occupy exactly that amount of item, right? So here's what we need to do. We'll put our left pointer here and our right pointer at this position. Now, what this means is we've selected the first K items or the first K sub array in this array X here, right? And then we begin to find the maximum sub array in this array here, in this X array. So the maximum sub array will be found by sliding the window across the array. In other words, we will move the left pointer and the right pointer simultaneously. So let's do it this way. So in every iteration, we'll move the left pointer and the right pointer to the next 2 items, right? And so this is how we move. We'll move the left pointer from this point. Sorry. So the next 2 items in the array, currently we have just our first sub array will be 1 and 3, right? The next sub array will be 3 and then 7. So we'll move to 3 and 7 like this. So we shift the left and right pointer. Now, when you observe this very well, right? Let me just do it one after the other. So let's say we move the right pointer to the next item, right, towards the right, and the left pointer to the next item towards the right as well. Now, our window still maintains the size, but what we are doing now is we are excluding, or we are removing an item from the window and introducing a new item to the window, right? We are removing one item and adding one item to the window. Sorry, I have to get this. So we remove one item from the window and introduce a new item. Now our window will still maintain its size. Sorry about the the quick break that I took right now. So here's what, if you look at this, right, you can see that 1 was removed in this new window, right? 3 is still maintained, but 7 is now added to the window. We still have 2 items in our sub array, right? But we want to find the maximum sub array sum. So for us to do that, right, for every item we see, we need to calculate, right? Since we are calculating a sum, we have to add those 2 items, right? We find the sum of those 2 items. So in this case here, this will be 4 and this will be 10, right? So let me write 10 very well. So this will be 4 and the second sub array will be 10, right? We remove one item from the array and we add another item. Now we found 10. 10 is superior to 4, which was the previous maximum we found before. So we keep 4 as our, we keep 10 as our current maximum, right? 10 will be our new maximum. I don't need to put it anything. So 10 is our current maximum. So we slide the window across the array again by removing one item from the window and adding a new item to the window, right? So we add a new item to the window, which is 4, and then we remove 3 from our window this time around. It's still the same as just sliding them, right? What I'm doing now will happen within a particular iteration, one iteration, right? So we move the right pointer towards the right, and then we move the left pointer towards the right as well. They will move simultaneously. They will move one after the other. So now we move it like that. Our current window will have 7 and then 4, right? 7 and 4, and the current maximum here will be 11, right? So 11 is our current maximum, right? Because 11 is superior to 10. So now we found our current maximum, so we continue doing the same thing, sliding the window across the array, right? So we move the right pointer towards this point and the left pointer to this side, right? Now you can see at this point here we have 6 and 4, right, in our current window. So we removed 7 from the window and then we introduced 6. So the current maximum here is 10. I mean, the maximum in this iteration is 10, but it is not superior to our former maximum, or let's say our I mean the sum here is 10, but 10 is not superior to our maximum, so we keep 11 as our maximum still, right? And then we slide the window again. We move the right pointer towards the right. Now right pointer is at the end of the array, so we can't move it any further, and the left pointer will come to this point, right? So the current window will contain 6 and then 11, right? And this is going to be 17. So 17 is our current maximum. So we return 17 as the sum of 2 items or 2 consecutive items in the array that will form a sub array, right? Whose sum is the maximum, right? Is the maximum of every consecutive 2 items in the array. So from this point to this point, from this point to this point, from this point to this point, and so on, right? For every sub array of length 2 in this array X here, the maximum is 7, right? The maximum we can find is 17. Sorry, the maximum we can find here is 17. So now that is a general idea for sliding window when we know the size of our window, right? When we know the size of our window. But in the case where we don't know the size of the window, right? In the case where we don't know the size of the window, let's say instead of calling this K, right, I'll call this target, right? I'll call this target T. T is going to be target, and I'll say, let's say the size is equal to, let me change this to 8, right? And say this is equal to 17. Sorry, this is equal to 12, right? So we want, okay, I'll not call this 12. I just want to give another example. So let's call this maybe 20, right? Let's just use 20 as an example. 20. Okay. Now we want a sub array, right, such that the sum of every item in the sub array is superior or equal to T here, right? We want a sub array such that the sum of every item in the array is superior or equal to T. Now this time around, we don't know how many item has to be in the sub array, right? In the other example, we know the sub array has to have 2 items, right? But in this case, we don't know how many items is supposed to be in the sub array, right? So here's another technique. Sliding window technique will be used, but there is another trick to questions like this. When you don't know the size of the array, when you don't know the size of your sub array, right, we typically start both pointers at the same point. Now here's where we will use the expanding and shrinking method, right? We'll use this, we'll start at this point, right? So um we'll say the let me start my left and right pointer here. So I'll use a different color. Okay, my left and right pointer will start at the same position, right? They'll start at the same position, and the window will begin to increase or shrink depending on the situation, right? So let's say we are looking for um you know I want to set t to a different value, right? So that we can look at the shrinking and expansion. Um, so this is 7. This is going to be 11. 11 plus 4, that's 15. 15 plus 8, that's 23. So, okay, you know what? Let's just use this and say we want the sub of a sub array from this X array here, such that that sum of every item in that sub array is exactly equal to t, right? Let's just do it that way. If we don't find anything, we can just return null. But in this case, let's just find out, the sum of every item in a particular sub array, right, derived from this array here, obviously, such that the sum of those items is superior. I mean, is exactly equal to t, which is 20 here. So for us to do that, right, we can use a sliding window technique by setting the 2 pointers at the beginning of the array. Now we will begin to increase or expand our window by moving the right pointer towards the right. Now at this point, these two items will form a sub array. Even at this point here, this item here, right, the position of let's say x at 0 and 0, right, will give us 1. Now 1 is less than t, right? 1 is less than t, so we can move the right pointer towards the next item, right? We can move the right pointer towards the next item to increase the window. Now this time around, our window has 2 items, right? So our window would look like this: 1 and 3. Now the sum of 1 and 3 is equal to 4, which is still less than t. So we increase the window again. We expand the window by moving the right pointer, right? Now at this point, we'll have 10, right? So our calculation, this will typically be equal to, so our window will look like this. Our window started from this point to this point, right? So it will contain 3 items. So the array will look like this from L towards up to R, right? This will be 1, 3, and then 7, right? This is going to be 10. 10 is still this is 11. 11 is still less than t, right? We'll do the same thing for the next items by simply expanding the window, right? Now we continue expanding the window because our condition here is not yet violated, right? If the condition is violated, then we shrink the window. So our new window will look like this. So we'll have let me remove this line here. Our new window will have 1, 3, 7, 4, right? The sum of every item here is going to be equal to 11 plus 4, 15. 15 is still less than t, right? So we expand the window again. Sorry, I forgot to move the r here. So we expand the window by including the next item in the array. Now this is going to be equal to, so our array will look like this, or our window will contain 1, 3, 7, 4, and then 8, right? Now we are adding 8 to the window. So in this case, right, the total sum here is going to be 15 plus 8, which is 23, right? So 23 is superior to t, right? 23 is superior to t, so we shrink the window. We shrink the window by simply moving the left pointer towards the right until the conditions are satisfied again, right? If we move this from here to here, right, we'll still need to find out if the current window is either less or equal to t, right? The current sum of the sum of the current window is either less or equal to t. If it's equal to t, we stop the iteration. If it's less than t, then we increase the window once again, right? So we find our current window after shrinking the window, right? Because at this point, let me write this out again so that it's really clear. I'll use a separate color to do this. So I'll use a different color to do this. So this, our current window will look like this. We'll have 1, 3, 7, 4, 8, right? 7, 4, 8. And this is going to be equal to 23. And we know 23 is superior to t. T is equal to 20. So we can't use this current window, right? So we need our condition is now violated, so we need to shrink the window. So for us to shrink the window, we simply move the left pointer towards this point until the conditions are okay once again, right? What is okay? Okay is when the sum of every item in the window is either less or equal to t, right? So we find the current sum after shrinking the window, right? We'll have the current sum will be 3, 7, 4, 8, right? 3, 7, 4, 8, because we removed 1 from the window. So after removing 1, right, we'll still find the total sum. This is 10, 14, and then this is going to be 22, right? So 22 is still superior to t. So we shrink the window once again. Now note that we've not moved the right pointer at this point, right? So we continue shrinking until the conditions are the condition are valid once again before we continue increasing the window. So we remove 3 from the window, right? We remove 3 from the window. I'm running out of space here, but I'll manage the position, the bottom space here. So we'll have our current window has shrunk again once again. So the items we have in the window will basically be 7, 4, 8, right? 7, 4, 8, and we'll find the sum of 7, 4, 8. So this is 11, this is 19. So 19 is less than t, right? Since 19 is less than t, we can expand our window once again, right? We can increase the window to accommodate more items. So we do that, and our window will look like this. We could include every item from 7 all the way to 11, right? All the way to 11. So say 7, 4, 8, and then 11, right? Now the sum of every item here is going to be equal to 30, right? 30 is superior to t. 30 is superior to t. So we shrink the window once again. We move the left pointer towards this point, right? And you can see that's basically the idea. When you don't know how much of items you are supposed to include in your sub array, right, or in your window, you start the left and right pointer at the same point, right? You start the window as a single dot or at a single point, right? And then you begin to expand the window by increasing or by moving the right pointer towards the right, and the left pointer when a certain condition is violated. So again, we will shrink the window, right? We'll move the left pointer to this point. We'll remove 7 from our window. So we'll have 4, 8, 11, right? This is our current window. So this is going to be equal to 23, I guess. 23 is still superior to t. So we move the left pointer again, right? The left pointer will be at this point. So I mean, we'll have just 8 and 11, right? 8 and 11 is 19. 19 is less than t, but we can't increase our right pointer at this point, right? We can't move our right pointer anymore because our right pointer is at the last item, is at the position where the last item appears, right? So we can't move it anymore, so we stop our iteration. This is just a basic idea, to understand in order for us to solve this problem here, right? Now I'll erase everything here, right? That's just an example I gave, so let me remove everything that is here now. Okay, so now our question is 713 subarray product less than k. Now this is the solution here, but we'll go into the solution. You know what? I don't think I should even. Okay, it doesn't matter. It doesn't matter anymore. I did think I should erase whatever was there, but okay, we can still continue solving the question. Given an array of integers nums and an integer k, return the number of contiguous subarrays where the product of all elements in the subarray is strictly less than k. Right? Now, what do we know here? We know that we are given an array, obviously. That is what the question is based on. But we also know that an integer k is our target, right? Now we want to find the number of contiguous subarrays where the product of all elements in that subarray is strictly less than k. Now, compared to the previous example I gave, right? In this case, we are simply going to find the sum, the product, right? Multiplication. Product involves multiplication, and in the other example I used sum, which was addition. So first of all, we know that our subarray can have any amount of items, right? It can be a subarray containing just a single item or multiple items, given that the conditions are actually valid for us to have multiple items for that particular subarray. So here's what we need to do. Well, we'll first of all find the product of the first items in the array and then expand our window to accommodate more items in the subarray, right? And then once we added as many items in the subarray, if the conditions are okay, or if these conditions are not violated, then we continue to add more items to find the product of those items until the conditions are not the condition is violated, and then we shrink the window. So we'll start our left and right pointer at this point, right? So a window of an unknown size, the left and right pointers will have to be will have to be at the same position, right? They have to start at the same point, and then we increase the window, we expand the window or shrink the window depending on whatever happens, right? So oh, I have a couple of chats. Sorry. Oh, okay. Hello. Hello. Chiwaya said solve Leetcode array problem. Well, there are a lot of Leetcode array problems. The one I'm solving now is on subarray, right? Which is a sliding window problem. So stay tuned for that. Okay, so let's get back to our question. So we will start our left and right pointer, or we'll start our window at this position here, right? So the left and right pointers will be here. Now we'll increase or expand the window, given that a certain condition is okay for us to do so. So here's what we need to do. We move the right pointer towards the right, right? So this is first subarray, right? First subarray. Obviously, this is less than k, right? A subarray could be just an array with one item in it, it doesn't matter, right? So one item in the array is still less than k. So at this point here, we just have one count so far. Now we want to count. Read the question again. So we say we return the number of contiguous subarray. So we want to count how many subarrays in this array, such that the product of every item in those subarrays are the product is less than k, strictly less than k, not less or equal, less than k. So our first check, right, will be at this position, right? So we'll be here, the right pointer will also be here. So obviously this is less than k, right? So this is less than k, 10 is less than k, so that is one count. So we have count, I'll put a count here. A count here is going to be equal to 0. It's going to be equal to 1 for the first item in the array. Now the second time we'll move the right pointer towards this point. Now our sub array will contain 2 items, right? So here's what we need to do. We find the product of these 2 items at this point, right? Because we don't know how many items our sub array has to have, so we find the product each time we add an item to the sub array. So the window, each time we add an item to the window, so the window will have 10 and 5, right? In the second iteration we'll have 10 and then 5, right? 10 and 5, the product of 10 and 5 is 50, right? 50 is less than 100, or 50 is less than k. So which means this condition is also valid for this condition, right? This solution, did I say this condition? Okay, this condition is valid. I mean, the product of 10 and 5 is 50, which is less than k, so we can count that as another sub array that validates this condition. So our count here is going to be equal to 2, right? So we then increase the window again to include one more item in the window, right? Because our window does not have any fixed size, so we can add as many items as we want into the window until the condition is no longer valid, right? Or the current solution is no longer valid, then we shrink the window. So after expanding the window, right, the right pointer will include 2, right? So we'll have our current window will include 10, 5 and then 2, right? Now the product of every item in this window is going to be equal to 100, which is equal to k, right? This is equal to k. We don't want anything equal to k, we want everything less than k. So since this is equal to k, which means obviously this has violated our condition, so we need to do what? We need to shrink the window, right? We need to shrink the window by moving the left pointer towards the right. Now, one thing to also note is that for us to remove 10 from our window, right, we'll do it the same way we remove an item from a window where we are summing up every item. Since we are dealing with multiplication, to remove an item from the window, we simply divide the current product, right, by the item we want to remove from the window. So we want to remove 10 from the window, so we divide this by 10, so this will give us 10, right? So our current window will have 5 and then 2, right? And the product of 5 and 2 is 10, which is what is here, right? So now at this point, right, we would not increase our count because 10, 5, 2, right, is not a valid product that is less than k. So we leave our count until we remove this 10 from the window, and then we find the product of the remaining items in that particular window, which is going to be 10. So this is going to be equal to 3, right? So that is 3. Who is there? What do you want? The code is 6069. Sorry about that. Again, we've counted, so our left pointer would have moved from this point to this side. Now there is something else missing, right? Remember how we had, sorry. Okay, I need to put this back. Remember how we had the left and right pointer at the beginning, right? Which was good, obviously, but we were trying to signal that an item, a single item, can be part of the window, right? Can form a window, right? Or can be a valid product for k, right? So which means 5 has to be checked for this product as well, right? But we can't directly find the product if we are constantly, we can't directly point to 5, right? Like this, if we are constantly increasing the window, right? If we are increasing the window, when do we, how do I put this? In what condition, how would we move the left pointer such that, they both point at the same item at the same time, right? How would we be able to do that? Because we want to count every sub array such that the product of the items is less than k, and 5 is also a sub array of the nums array here, right? 5 is in nums array, so it's a sub array. Automatically it makes it a valid candidate for the product of every sub array less than k. So for us to the reason why we even need to do this here is for us to increase the count, right? To know how many sub arrays we've seen so far. So in that case, we will need to tweak a bit our strategy of calculating the count. Instead, we need to increment the count by simply calculating the distance between the left and the right pointer, right? At this position here, the distance between the left and the right pointer will be equal to 0, right? Will be equal to 0 because the left and the right pointer are at index 0. So let me represent the indexes here. So this is going to be index 0, this is 1, this is 2, and this is 3, right? In every iteration, regardless of whether the condition is valid or not, one of the pointers would have moved, right? It's either the window will shrink or the window will expand. So whatever it is, right, we need to still find out the distance between those two pointers at every point in time. In other words, within every iteration. So when we move the right pointer, the left and the right pointer at this position, right, the item here is a valid sub array, right? For this condition, it's less than k, a valid product of a valid sub array. Yes, let me just put it that way, a valid sub array, because the product of every item in the sub array is less than k, right? So nums at this index here, at index 0, is a valid product, right? If it's a valid sub array. So for us to count how many items we've seen so far, or how many sub arrays we've seen so far, we simply need to find the distance between the left and the right pointer. Now the distance between the left and the right pointer would be to subtract, right, the left pointer from the right pointer, right? Because the right pointer will move farther than the left pointer, right? So we can do that. Instead of incrementing the count like this, I'll say count is going to be equal to count plus the distance, right? The distance is going to be the left sorry, the right minus the left pointer. Now, the right minus the left pointer here is going to be equal to 0. But we've seen we've seen we've seen 10 so far, right? 10 is a valid sub array of this array here, right? So but the distance between these two would not be sufficient, right? Because I mean, if we do 0 minus 0, we still get 0. Meanwhile, we've seen one item already. So for us to properly calculate the distance, right, we need to start counting from 1, right? Which means we have to include 1 to this. Now this is simply because we started counting from 0, right? So we do right minus left plus 1, and that is how we will find the distance between these two. And in every iteration, right, we'll subtract we'll subtract from the right pointer the left pointer, right, the position. So these are simply indexes, and then we'll add the sum of this, right? We'll add this calculation here to the previous count to count how many sub array we've seen so far. So this will no longer give us the problem of having to point at the same item in the sub array, right? So we'll simply continue moving our window, or expanding our window and shrinking it when a certain condition is violated. So that's about it. That's how we'll solve this problem. And and oh, sorry, I didn't even see your message. I am so sorry. So it said, "Hi, what are you doing?" I'm solving Leetcode question. I'm studying Leetcode questions. I mean, studying how to solve data structures and algorithm problems. Yes. Just give me a minute. I'm almost close to the end of the stream, so I can answer every one of your questions. Okay. So yeah. Then for us to solve this now, you can see here is the solution to the problem, right? So we will, first of all, find the product of every item in the window so far, right? And then we will shift our left pointer towards the right if the current product is superior or equal to k, right? Now we will then remove one item from the window, or from the current products that we found, by simply dividing, right? Dividing the product by the current by the item we want to remove from the window, right? And you can see we calculate the count by just doing this, right? By just subtracting from the right the left value and then adding 1 to it. Then at the end of the day, we return the count. So that's how we can solve this question. I think I'll need to put the solution on GitHub for you guys to have access to it. I tried this question, obviously. I tried this yesterday, right? And my solution did not work. So, but by putting in more time to understand the question, I was able to get it at the end of the day. So, I mean, the only edge case here is that, when k is less than 1, right, less or equal to 1, we have to return 0, because the product of two items, right, two items in a particular array will never be equal to 0, or any item in the array. Now that is only true if the array does not contain 0, because at the end of the day, if the array has 0, then we are in trouble, right? We are in trouble. So I think when you read the constraints, right, you see that the norms will always contain items from 1 up to 1,000, right? So that's already a hint that will at least have a product that is of items that is not going to be equal to 0. So let me do this quickly. So if this is less or equal to 1, right? If this is less or equal to 1, then we want to return 0, right? Sorry. What's going on here? Oh, I did put the if. Christ. How would I forget that? So we want to return 0. Okay. And then now we'll begin to define. So we'll have a left pointer is going to be equal to count is going to be equal to 0. So count, and then this is going to be equal to 0. I'll just put it this way. This is still the same as left equal to 0, count equal to 0, like this. Left equal to 0, count equal to 0. Okay, let me just put it like this so they are on separate lines. And so the next thing we did is the product, right? So we'll set the product initially to be equal to 1. So product is going to be equal to 1 at first. Now, why is product equal to 1? Because any number multiplied by 1 is simply going to equal to that same number. So we'll then iterate. So from nums in the nums array, right? For every item in the nums array, we'll simply find the product, right? So the product is simply going to be equal to product star equal to nums. Now this is also the same as sorry, this is also the same as, okay, this is also the same as product equals to product product types nums, like this, right? This is the same as that. So whichever one you prefer, but I really like to go with this, right? Because I am also used to doing something like this: count plus equal 1 if I want to increment the count by 1. So they are all the same. So let's say, okay, so we found the product, right? Now the next thing is for us to check if the product we currently have, right, is superior or equal to the k value, right? Or in other words, if our current window has items whose product is superior to the k value. So we'll say while there is an item, while there is a window that violates the condition, we'll remove every item from the window, right, until the window is valid again. For until the window is valid again to get product of every item less than k. So here's how we need to. So we use a while loop. Now a while loop will help us do this until the condition is false again before we continue. So while the product is superior or equal to k, right? While the product is superior or equal to k, then we want to move the left pointer, right? We want to remove the item at the left pointer and shift the left pointer towards the right. So here's how we'll remove an item from the left pointer. So we'll simply do product, right? Product. So we'll divide the product. Now you can use the double equal sign because this will round the division back to the nearest zero value, right? So we'll say nums at left, right? And then we'll say then we've removed the item at the left pointer at this point. Then we shift the left pointer to create a new window or to shrink the window. So we'll say left plus equal 1. So left plus equal 1, right? So meaning we've shifted the left pointer towards the right, right? And it doesn't matter whether the current product is superior or equal to k, but we need to increment the count in every iteration, right? So we say count is going to be equal to the right pointer. Sorry. Now look at what I did here. We want to access the right pointer and the current index and the current item, right? So for us to do that, right, we can do it this way. We can say right and then num, right? Right and num in enumerate, right? So enumerate will give us access to an item and its index, right? So this way we can get um the right the right pointer, right? Now you can even create the right pointer outside, right, and set it to 0 and increment it within the loop. That is also fine, but a cleaner way to do this is to just set it inside here. So we can say right minus left, right right minus left, plus 1, right? And then at the end of the day we'll return the count, so which is what we are really interested in. And yeah, so here's the solution on Leetcode, right? If you after submitting this, you can see the runtime is really good, and I mean not so much in terms of space, but yeah, we are good with that, right? So that's how you solve this solution, this question, sorry. Why did I say solution? So when you run this, I usually test in my environment here. Now you can see this is not so okay. So I made a mistake here. So what is the mistake? Let me see. So there's something wrong here. It says this is not supported between instances of list and int. Which one is a list? K is not a list, obviously. Product is not a list too. So why is this saying it's not supported in two instances? Oh, so I'm multiplying nums like this instead of using num. So sorry about that, right? So yeah, sorry. We need to return outside, not inside the loop. Okay. Yeah, so that's about right. I will push this to GitHub. So I'll say git add git commit dash m, and we'll say this is this is a sliding window problem. So I'll call this sliding dash window. This is Leetcode 713 leads dash 713, like this. Okay, so complete push origin main. Yeah. Oh, sorry, I have some questions. I'm so sorry. Can you provide a Java solution for the same? No, I will not say I don't code in Java. So, but the steps will probably be the same, right? I am sorry, I don't code in Java. I don't code in Java at all. So let's see. Any other questions? I'll be happy to take some questions today. Um, mm, any questions? Before I go? I think I'm at the end of this stream. Tomorrow I have another section. Is there any other questions? So I'll wait 5 minutes. I'll wait 5 minutes to see if there will be any questions. Um, but while I'm waiting, right, I'll quickly go through some questions I've solved before. So let's see. We have. I'm so interested in linked list, right? I don't know. Maybe it's a it's a toxic love I developed for linked list, but it's just fascinating to me how the idea of nodes and linking to one another. We have a node pointing to another node, and you have a tail. You can remove an item from a linked list by simply changing the next pointer of that particular item, right, to the I to points you to remove. Let's say we have a node like this, right? We have a linked list with nodes like this: 1, 2, 3, 4, right? And usually the last node in the linked list points to none, right? It will point to none. So for us to remove, let's say we want to remove 2 from our linked list, right? This node here. We want to remove this node from the linked list. Now, one way, I mean, if you're not familiar with linked list, right? You might think, okay, removing an item from a linked list is simply removing, or there's a method, there's a function that deletes item from a linked list. But in reality, it's not like that, right? To remove an item from a linked list, you simply direct the pointer before it, right? Or the node before it to point to the node after it, right? And that way, it's simply removed from the linked list, right? So this node has a next value, right? This node 1 here has a next value, and its next value is pointing to 2, right? For us to remove 2 from the linked list, we simply point two's next one's next pointer to the node after 2, right? We'll simply do something like this. So instead of 1 pointing to 2, 1 will now point to what? To 3, right? And then we just, you know, I'll say salvaged two from the linked list, right? It's really, fascinating. I will solve linked list questions so much that I'm really good with. Get very good with linked list. I like linked list a lot. Um, but yeah, Leetcode just makes it funny sometimes. You just solve the questions, and I mean, you just read some questions and you're like, what's this? What's this question? Right? So, um, for a big surprise, right, we can, Adam, I'll continue doing this, solving these questions for a long time, right? Okay. I think that's it for tonight. Um, I might. I'll continue tomorrow. I'll continue tomorrow solving these questions. Tomorrow will be a great day. Tomorrow is another day to try. And I've learnt a lot so far, right? Thanks to everybody that has been coming here, um, everyone that has subscribed to my channel. Oh my gosh, I've get new subscribers. This is good. Thanks to everybody, and I will see you guys tomorrow. Bye. I don't have any more questions, so let's end the stream today. Thank you, guys.